Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now we are happy to announce that we are going to providing the training for the students who are writing the GATE and engineering service examinations. For those students, we are providing online training. So I'm welcoming you all to this beautiful learning platform. Now at present outside situation, all of you know that outside situation is not good. So students are fearing to come out. Not only students, everyone, human is going to fearing about to coming out of the home. So in this pandemic situation, whatever thing is happened at outside, but your learning process should continue because that is our future. In that aspect, we started this. With that intention, we provide a continuity in the learning, students' learning process. We started this platform. Now I'm welcoming you all to this beautiful online learning platform once again. Now about myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present I am pursuing PhD from JNTU Kakinada. My specialization is VLSI design. Now first we check how to get this Unacademy learning app into your device. Just go to Play Store in your device. Type Unacademy in that. Then you get the Unacademy learning app like this. Just click on this install button. Here is the install button. Just click this install button. By clicking this install button, it will install the Unacademy learning app into your device. After installation, just if you open that app, it will show us what are the different courses available in Unacademy, and in each course what are the different subjects we have, and different subjects with each subject who are the top faculty handling that subject. Okay, so you get that information. Now see this, here your classes are taken care by the India's top educators. How I am going to claiming that India's top educators is because of see this Tiwari sir, he is the IIT topper. So because of that we are claiming that top educators are handling your subjects. Topper Ankit Goyal sir, he obtained 2 times All India first rank in GATE electrical, to All India first rank 2 times in GATE electrical, and he was awarded President of India gold medal in IIT Indore. Okay, so because of this we claimed it as a topper. Now Jaspal Singh sir, he is ex-IAS officer, he is All India 4th rank. Okay, All India 4th rank. So we are claiming him as a topper. So I like that. Now here is the faculty having more than 8 years of experience. Okay, having very sound experience in teaching the students. So because of these wonderful faculty, we are claiming that top educators are going to handling your subjects. Now here are few more faculty, top educators from there belongs to different departments. Now we are happy to announce that recently we started 2 batches, 2 new batches, one for GATE 2022 and other one is for GATE 2023. There is a ascend batch for GATE 2023 for mechanical engineering. Here are the top faculty who are handling the subjects in that, and this batch started from 22nd February 2021. And don't forget to use my code VRAO10 during subscription to get the 10% discount. VRAO10 to get 10% discount. Next we move to Evolve batch for GATE 2022 for mechanical engineering itself. This batch started from 22nd February 2021, and the same faculty who are handling these subjects in GATE 2023 The same faculty are handling the subjects of it. And now we move to a civil engineering side. There is a Spark batch we started recently. February 2022, we started this Spark batch for civil engineering students. This is English batch. English batch. So here are the top faculty handling the subjects in this batch, and this batch was started from 22nd February 2021. And similar to this type, there is a mission DDR we started. Mission DDR we started for mechanical engineering students for GATE 2022. For GATE 2022. So this batch started from 22nd February 2021. Here are the top faculty who are handling the subjects in this. And don't forget to use my code VRAO10 during subscription. VRAO10 during subscription to get 10% discount. Next, there is a Ascend batch for GATE 2023. Ascend batch for GATE 2023. This is for civil engineering. Here are the top faculty: Jaspal Singh sir, Gil sir, Chagi sir, Dushant, Abhishek Kumar, Andrit Singh Rathore. So here are the top faculty, top educators handling your subjects. And this batch started from 8th February 2021. Next, there is a Eval batch for GATE 2022 for civil engineering itself. The same faculty who are handling the subjects in GATE 2023, the same faculty are handling the subjects in GATE 2022 also. And this batch started from 8th February 2021. Now we move to computer science and information technology. So there is a Eval batch for GATE 2022. Eval batch for GATE 2022. Here are the top faculty who are working under this batch: Ravindra Babu sir, Rao sir, Sanchit Jain sir, Subbarao sir, Mallesham, so Vishwadeep Koti and Sweta Kumari ma'am. Here are the top educators who are handling your subjects here. And this batch started from 8th February 2021. And if you observe the students in computer science at IITs and NITs, 50+% of the students are the students of Ravindra Babu sir. That is his reputation. Okay, that much famous faculty here. And the first online training, online classes for GATE started by sir itself. And next we move to electrical department. Now there is a Ascend batch for GATE 2023. Here are the top faculty who are handling the subjects in that. This batch started from 1st February 2021. Okay, and here are the top educators who are working under this batch. Now we move to the Ascend batch for GATE 2023, Electronics and Communication Engineering. Okay, and here are the top faculty who are working under this. This batch started from 1st February 2021. And don't forget to use my code VRAO10 during subscription to get 10% discount. Next we move to Evolve batch for GATE 2022. There is Evolve batch for GATE 2022, Electrical Engineering. Here are the top faculty who are handling the subjects in this batch. This batch started from 1st February 2021. And similarly for Electronics and Communication Engineering also, there is a Evolve batch for GATE 2022. Same faculty, who are the faculty handled for GATE 2023, the same faculty handling the classes of GATE 2022. Okay, so this batch started from 1st February 2021. Last but not least, now we are moving to chemical engineering. And so most of the students are wondering about this because chemical engineering training is available. Is it true? Yes, it is true, because throughout India, hardly 1 or 2 locations only chemical engineering training for GATE examination is available. Okay, now for the students who are doing the chemical engineering, for them it is very difficult to move from their location to that location to get the training. In that aspect, we started this online training for this chemical engineering also with the top educators. Okay, so here are the top faculty who are working under this. Now, just we glance what are the different engineering disciplines available for GATE and engineering service examinations. ECE, Electronics and Communication Engineering, Chemical Engineering, Computer Science and Information Technology, Mechanical Engineering, Instrumentation Engineering, Production and Industrial, Chemical Engineering, and Electrical Engineering. Here we have two plans. One is a plus subscription, other one is iconic subscription. Plus subscription is the basic plan. In this subscription, your classes are taken care by India's best educators, and there are interactive live sessions are there. Structured courses and PDFs are available to you, and live tests and quizzes are going to be there. In iconic plan, we take your preparation, your GATE and engineering service exam preparation to the next level with personal coach. So similar to plus, here India's best educators are taking your classes, interactive live sessions are there, structured courses and PDFs are there. Next, live tests and quizzes also is there. Now, once you've written the exam, your exam paper is completely analyzed by the faculty or the personal coach who are provided to you. He will analyze your paper, then he will know that what are the different problems you have, in that in which problem you solved effectively, that means in which topics you are strong, in which topics you need a preparation, which topic you are going to committing mistakes, everything he will note. Okay, and they will identify the gaps in your preparation, and to fulfill that gaps, we will prepare a proper study planner to you. Okay, and we prepare a proper study material also to you. By following just these two, every student gets success in their examinations. Okay, that is the iconic plan. Now just we check the price for each one. Now the price is a nominal price. For plus subscription, if you observed 1 year, 1 month, 3 months, 6 months, 12 months, 18 months and 24 months subscriptions are there. For every student, minimum, as a faculty I recommend to the students to take minimum of 1 year subscription. Now see, 1 month, 3 months, 6 months, 1 year, 1.5 year, 2 year subscriptions. As a faculty, I recommend the students to take minimum of 1 year subscription. Minimum of 1 year subscription. Okay, in this 1 year, this 1 year is required for a student to get to complete the preparation of all subjects, to write more number of examinations, and to identify where the student is strong and where student required more preparation. Okay, that means to identify the gaps in your preparation, you need to spend minimum 1 year. You need to prepare subjects and revision the subjects, write the exams at the subject topic level, subject level, grand tests you have to write, and after that you have to identify the gaps in your preparation, and after that you need to go for examination. So for doing all these things you need minimum of 1 year, and the cost, if you observed, it is 30,250 rupees. By using my code VRAO10 during subscription, you get it by 27,225 rupees only. That means you get it by 10% discount. Okay, now if you compare the cost, this cost with the amount of amount what you are spending for traveling throughout the year to take a training somewhere offline in your city, its cost is around 20,000. Now just by adding few amount to that, you get the benefits more than that. And more important thing is, no need to move anywhere. Just by staying at your location itself, you can get the training. Now we move to iconic plan. In iconic plan, there is a 1 year subscription and 2 year subscriptions are available. 1 year subscription is 50,250 rupees. Okay, by using my code, its cost is 45,225 rupees only. 45,225 rupees only. Okay, now here we are providing this cost. If you compare the cost what you need to spend for at outside for taking the training, for offline training, whatever the amount you need to spend there at outside, you are paying the institute that amount only. With that amount, we are providing training. At the same time, personal coach we are providing. We will take care of your academics and your preparation throughout the year, from first day of registration to end of the day for that 1 year. Okay, every minute we observe your academics and your preparation, your progress, everything we can analyze, and we guide you, we suggest you in a proper direction. We keep you keep to move in a proper direction, and we identify the gaps in our preparation, we fulfill those gaps, and we make you like a loaded gun for your examination. That is the motive to go for a personal coach. Because of that only we are charging this amount. And don't forget to use my code VROUT10 during subscription to get 10% discount. And students, please think once of it. Discuss with your parents, discuss with your friends, and discuss with your faculty who are having knowledge on GATE and engineering service examinations, and take a right decision. Okay, thank you. Now we move to our today's topic, problems on transistor. Problems on transistor. Okay, now already we have some idea on transistor. You know what is transistor. Simply, transistor is going to transfer the input signal current from low resistance region to high resistance region. Sorry for delay. Now we move to problems on transistors. Now so the first important thing here, I am going to writing the few formulas what we are going to using in the transistor analysis. The first point is, the first equation is emitter current. Emitter current equals to base current plus collector current. And alpha CB current gain, that is IC by IE, comma beta CC current gain, CE current gain, IC by IB, IC by IB. Now gamma CC current gain, IE by IB. The relation between these three parameters is gamma equals to 1 plus beta equals to 1 by 1 minus alpha. And another standard equation for IC is beta times IB plus 1 plus beta times IC naught. IC is another equation. This is in CE configuration. In CB configuration, IC is minus alpha into IE plus IC naught. This is the current equation of transistor in CB configuration. And we have two more additional current components. ICB naught. It is the collector current. Collector current in common base configuration when third terminal emitter is open equals to IC naught. Similarly, ICE naught is, it is the collector current in common emitter configuration when third terminal base is open circuit, which is 1 plus beta times IC naught. Okay. So please, my dear students, please take a note of these formulas. Next we are going to work out on this. Please take a note of this. Okay. Now, see this first problem. For a transistor, for a BJT, the common base gain alpha equals to 0.98. Alpha is 0.98 and collector base junction saturation current IC naught 0.6 microamps. This BJT is connected in the common emitter mode and operated in active region. The base drive current IB is 20 microamps. The collector current for this IC for this mode of operation is. Sir, they want the collector current. We know the equation for collector current. IC is beta times IB plus 1 plus beta times IC naught. Here they given alpha, they given IC naught, fine. IB also, we need to calculate beta and 1 plus beta. We know that beta equals to alpha by 1 minus alpha. Okay, just substitute the values. 0.98 by 1 minus 0.98. 1 minus 0.98. Okay. So light sound. So 0.98 by 0.02. Just simplify this. Now you get it is by 49. You get it 49 beta value. So once you know the beta, we go for 1 plus beta. 1 plus beta is 1 plus 49. It is 50. So far we calculated the values of beta and 1 plus beta. Just substitute that values here. Therefore IC is beta is 49 into IB is 20 micro, 20 into 10 power minus 6 plus 1 plus beta, 1 plus 49 is 50 into IC naught 0.6 into 10 power minus 6. That means micro. Now it is 49 into 20. 49 into 20 it is. Just use calci. 49 into 20. It is 980. 980. So that is a 0.98 milliamps plus 50 into 0.6. That is 30, that means 0.03 milliamps. So it is a 0.98 plus 0.03 is 1.01 milliamps. See, my dear students, here just I follow the equation what we have. See, this is your final option. This is your option. Okay, 1.01 milliamps. See, just whatever the equations they given, just I followed those equations, not more than that. Whatever the equations we defined, just to be previous IE, alpha value, beta value, IC value, here another IC value, in CB1, other one is in CE mode, and special current ICB naught, ICE naught. So these are the standard equation standards. Now just I am going to using these, not more than that. Okay. Now that's why please note down all these equations. So this is our first problem. Now next we move to the next problem. See this, what they given. The DC current gain of a BJT, the DC current gain, beta value, clearly they mentioned it is beta of BJT is 50. So they given beta value 50. Assuming that the emitter injection efficiency is 0.995. See, emitter injection efficiency. Is 0.995. So you need to calculate base transport factor. Sorry. What is base transport factor? See, emitter injection efficiency we are representing it by gamma star, and base transport factor representing by beta star. Okay, they given one parameter, you need to calculate other one. So we have an equation that is alpha is gamma star into beta star. This is the another equation, just add this one also in your equations. So that is alpha can also be written as large signal current gain is beta star into gamma star. So we need to get alpha. They are given already beta value. From that beta just get the value of alpha. So now we have a relation that is 1 plus beta equals to 1 by 1 minus alpha. Now take this side, 1 minus alpha is 1 by 1 plus beta. Now take this alpha this side, this one this side. So 1 minus 1 by beta, 1 plus beta is alpha. So 1 plus beta minus 1. So it is beta by 1 plus. Therefore alpha is beta by 1 plus beta. Just a substitute value. 50 by 1 plus 50, 51. That is alpha value. Now I am calculating that. That is 0.98. 0.98. Now substitute values. So this is 0.98 equals to, you need to calculate base transport factor beta star into gamma star. They given it as 0.995. Okay, from this we get the value of base transport factor beta star, that is 0.98 by 0.995, that is 0.985, 0.985. This is the answer. This is the option B, 0.985. Okay, just whatever the equations previously we defined, I use that equations, not more than that. Okay. Now, just we go to the next problem. Third problem. For an NPN transistor, connected as shown in figure, and VBE is 0.7. So base to emitter voltage VBE, they given it as VBE, they given 0.7 volts. Given that the reverse saturation current of junction at room temperature is 300 Kelvin is 10 power minus 13 amps. So this is 10 power minus 13 amps. So reverse saturation current at a base to same junction, that is a base to emitter, that means emitter junction, that reverse saturation current is VBE naught, reverse saturation current. Okay, it is given as 10 power minus 13 amperes. The emitter current is, what is the emitter current in this transistor? See, if you observe one thing in this transistor, this is basically NPN transistor, and you can assume a two junctions like this. Like this. Now in this circuit what they done is, whatever the collector, base, those two are shorted. That means this junction is short circuited. That means no use of this diode. Only one diode is there. Initially this is the circuit. In diode point of view, this is the representation of the circuit here. Okay, here is the supply, DC supply they given. Now these two are shorted. Once this diode is short circuited, no use of this diode. Only one diode, it seems to be a single diode. Now the circuit equivalent is this is the equivalent of the circuit. Now it is also called as diode connected transistor, and they given as VBE voltage 0.7 volts and reverse saturation current value is I naught. They given as 10 power minus 13 amperes, and they are saying the current through this one is emitter current IE, because it is emitter junction, base to emitter junction. Now That emitter current is, I am using the standard diode current equation what we have, I naught. So I am assuming this is I naught, reverse saturation current, into e power VBE by eta Vt minus 1. Eta you can take default 1 because they did not specified type of junction, type of device. So you can take eta is 1, no problem. Now it is I naught into approximate value. Compared to this value, it is 1 is very much small. So e power VBE by Vt. So I naught 10 power minus 13 into e power VBE 0.7 volts they given by 26 milli 10 power minus 3. So it is e power 7000 by 26. Sorry, 700 divided by 26. That is a 26.92. So e power of that 4.9 into 10 power 11 is 10 power minus 13 into 4.9 into 10 power minus 13 into its value is 4.9 into 10 power 11. So now it is 4.9 into 10 power minus 12. Sorry, minus 2. You can write it 4, 9, 10 power minus 3. 49 into 10 power minus 3 amperes. So which is equals to 49 milliamps. So 49 milliamps. This is your answer. This is the option, right option. Okay. See, in this problem, just they given the transistor, but the equation we use is PN junction diode. We take our device into equivalent of its diode. Okay, the transistor is given, but it is given in its equivalent in the terms of diode equivalent or diode connected transistor we call it. So this is a diode connected transistor. Diode connected transistor. Okay, that is next problem. We are moving to next problem. Next. For a silicon NPN transistor, the base emitter voltage VBE is 0.7 volts and the collector to base voltage VCB is 0.2 volts. Then the transistor is operating in the region. Okay. Now, they given NPN transistor. Okay, first I am taking NPN transistor. So this is NPN transistor. Yes, NPN transistor. It is base, collector and emitter. Three terminals of the transistor. Now, what they given is base to emitter voltage 0.7 volts. Base to emitter voltage 0.7 volts plus minus 0.7 volts. Similarly, collector to base voltage, that means it is positive, it is negative 0.2 volts. Now they are asking the transistor is operating in which mode? Normal active mode, saturation mode, inverse active mode or cutoff mode. See, we have these four different modes. So here we have two junctions. So NP, this is one junction between collector to base, another junction between base to collector, base to emitter. So this is called as collector junction and this is called as emitter junction. Now the different modes of operations what we have is emitter junction. Let us take collector junction and I do one thing. This one also I write in the first page, and first page I will write these things. Let us take a transistor. Yeah, this is transistor. NPN transistor, default transistor is NPN. Emitter, base and collector. Emitter, base and collector. So there is a junction between this. There is a PN junction between emitter to base to emitter. Similarly, there is a junction between base to collector. Because of this only we called transistor is a back-to-back connection of two diodes. For better understanding of its operation you can use that, but physically it is not working like that. By connecting two transistors back to back it won't works like a transistor. Okay, now this is the junction between base to emitter. Simply we called it emitter junction and we called it collector junction. Okay, called it, one is emitter junction, other one is collector junction. Okay, now here we have two junctions, so we can bias these two junctions in four different ways. Now I am writing that. Let us take emitter junction and a collector junction. So next column is a region of operation. There is a special name for that region of operation. After that, it's a typical application. How you can use that transistor in that region. See, for example, both are forward bias. Emitter junction is forward bias and reverse junction also forward bias. FB in this sense forward bias. RB means reverse bias. or B, reverse bias. So both are forward bias. Then that region of operation is called as saturation region. And its application is it acts as a on switch. It acts as a on switch. That is the application. So next one is next. Emitter junction is under forward bias. Collector junction is under reverse bias. We call it forward active region or simply active region. Active region or normal active region or simply active region. Can be called it by different names. Active region and on switch. In saturation it behaves like on switch. Here it behaves like an amplifier. This is the application of the transistor under this region. Next, reverse bias, emitter junction, collector junction also reverse bias. Once both the junctions are under reverse bias, that region of operation is called as cutoff region. Cutoff region. Now its application is acts as a off switch. Off switch. Next one is last one. Emitter junction is reverse bias and collector junction is in forward bias. That is called, compared to active region it is reverse. So it is called reverse active region or simply inverted region. Reverse active region or inverted region. Inverted region. Here it acts as a voltage divider or simply attenuator. Attenuator or voltage divider. The default mode of operation of this one is in active region. This is the default region of operation. So we are concentrating mainly on this. Emitter junction should be forward bias and collector junction should be reverse bias. This is the default mode of operation. Now we go and check our problem. What is the region they given? Yeah. So here we have one diode. So base emitter junction, P connected to positive, N connected to negative. So emitter junction is forward bias. Collector junction, N connected to positive, P connected to negative. So collector junction is under reverse bias. So emitter forward, collector reverse. So this is our forward active region. Or active region. Or simply normal active region. So you can call it by any name. So this is your final answer. Okay, that is the option. So you should be thorough like this. First, you should know the possible regions of operation, and after that, go to a problem, identify which junction, that means which junction between base to collector and base to emitter is operating in which mode, that means which region, forward or reverse. Based on that, pick the right value from the table what we discussed just before. So now, see, consider the following statements S1 and S2. So here they given two statements, sir. S1 and S2, two statements they given. By considering these two statements, so S1 they given, S2 they given, is increased. This is these two statements they given. Now, which of the following is correct? So in this, which of the following statement is correct? Option A, B, C, D. Statement 1 correct or statement 2 correct or both are correct? Which one is correct? Which one is true? Which one is false? That is the day one they are asking. Now, I am going to first statement 1. First I am going to statement 1. It is the beta of a bipolar transistor reduces if the base width is increased. See, the beta of a bipolar transistor. So first write down the beta value. We know the beta value. This is the beta value. Beta is IC by IB. Now the first condition what they given is beta reduces if the base width is increased. See this. This is our transistor. This is the base region actually we take. This is the actual base we are taking. If base width is increased, so I am increasing the base width from here to here. What happens? What is the effect of this increment and base width on beta value? See, this is the regular case. If it is the base width, now recombination is like this. Now this one, some amount of recombination takes place at the base. By increasing the base width, the recombination is increasing. Recombination increasing in the sense base current is increasing. So therefore, by increasing base width, recombination at base increases. At base, recombination at base increases. Sorry. Recombination in base increases. Therefore, once recombination is increasing, IB increases. Therefore, IB increases. Finally, once IB increases, beta is IC by IB. It is increasing, beta has to decrease. So, by increasing the base width, the resultant is beta value has to decrease. This is the resultant what we get. Now check the statement what they given. The beta of a bipolar transistor decreases if the base width is increased. Okay, the given statement is true. It is true statement. So S1 is true. Okay, now we go to the second statement. The beta of a bipolar transistor increases if the doping concentration in base increases. So doping concentration in base, they are going to changing. The next one is S2 statement is the given beta, we know that it is IC by IB, no doubt at all. Now increases, it is going to increase if the doping concentration in base is increased. Okay, let doping in base increased. In base increase. Increase. Once base doping is increasing, IB increases. It results recombination in base increases. So majority carriers in base increasing, it results IC increases. Okay. Now, sir, IB increases. It results IB increase. Once IB increase, beta has to decrease. So beta has to be decreased by increasing the doping in base region. What they given? The beta of bipolar transistor increases, they are saying, if the doping concentration in base is increased. So they given as increase, but it is going to decrease. So this is the false statement. So statement 1 is true. First statement is true. Second statement is false. Statement 1 is true and statement 1 is true and statement 2 is false statement. So this is the correct option. This is the correct option. S1 is true statement and S2 is false statement. That is the correct option. Next. So we move to next problem. If the transistor in figure is in saturation, then see here they given the transistor. It is a NPN transistor. This is the collector terminal, base terminal and emitter terminal. This is they given it as a base current. It is base current, it is, and it is collector current. Then what they want is, then they are saying if the transistor is in saturation, then which of the below option is correct one? IC is always equal to beta DC times IB. IC is always equal to B minus beta DC times IB. So these are the options they given. Now just we check which option is correct in that. Now see, they given IB value and IC value. Okay, IB and IC. Just you need to identify transistor is if transistor is operating in saturation region, what is the condition? That is what you need to calculate. Okay. Next one. Now, first, how can you know the transistor is operating in saturation region? See, to get the transistor, to identify the transistor is operating in saturation region, based on the IC value, okay, you can easily mention. Now the IC value what we are calculating is, this is the IC flowing through that, and this is the IB flowing through that. By comparing these two, you need to represent the transistor is, if it is in saturation, what is the condition. Once they given IB, from this IB you need to calculate the IC value. From base current, see, from IB, IC is written as beta times IB. That means beta DC times IB. Beta DC times IB. That is the IC value. From this base point of view, with respect to base, the collector current should be this much. Okay. Now already they mentioned this transistor is in saturation region. Transistor is already in saturation region. Now this current, whatever the, with respect to base, in terms of base you defined collector current, it should be greater than this collector current. Then only this transistor will be in saturation region. So for saturation region, whatever the current in terms of base, the beta DC times IB current you have should be greater than or equal to the collector current what is flowing in the transistor. This is the required condition to take your transistor into saturation region in terms of base current and collector current. Now identify the correct option in this. IC is always equal to. So equal to is there, but at the same time greater than also is there. IC is always equal to minus BT. No, not option no. IC is greater than or equal to beta DC times IB. IC is less than or equals to, not greater than. IC is always less than or equals to beta DC times IB. So this is the right option. So that is the right option. Now we are moving to the next one, 7th question. A BJT has IB 10 microamps, beta 99, and IC not 1 microamp. Its collector current IC in microamps is IC beta IC not they given. So directly we have an equation for this. IC is beta times IB plus 1 plus beta times IC naught. So now I am using this. Therefore IC is beta times IB. So 99 beta into IB 10 micro plus 1 plus beta 1 plus 99 into IC naught 1 micro. So now it is, now its value is 990 microamps plus 100 microamps. So that is 1090 microamps. So option B is the correct one. Option B is the correct one. So please take a note of this formula, sir. So we move to next problem. See, if the base width in a bipolar junction transistor is doubled, which one of the following statement will be true? Current gain will increase, unit gain frequency will increase, base emitter base junction capacitance will increase, early effect voltage will increase. So just take the transistor. See, here what they are saying is whatever the base width they have, they are going to decreasing the width of the base region, increasing the base region. This is the actual base region. Now they are going to taking somewhat more double, just double the base. Now they are taking the base region this much. This is the base region they are considering. Just they increase the base this much. Okay, and current gain will increase. See, the current gain of the transistor, default current gain is IC by IB. Once base width is increased, recombination is increasing. Just before we observed. So once recombination is increasing, base current is going to increase, beta value going to decrease. So this is not right option. And unit gain frequency, unit gain frequency ft, we represent it as, okay, this is 1 plus beta times f beta, ce 3 dB cutoff frequency. So here beta value is, once it is increasing, beta value is decreasing. Once beta is decreasing, ft also going to decrease. So this is also going to decrease, but they given as increasing. So this is also not right option. Okay. Next, base emitter junction capacitance will increase. See, the base emitter junction capacitance means default capacitance between this junction is transition capacitance. Okay. Whenever, and this equation for this one is tau by RD. Okay. Now, this capacitance depends on, here base width is increasing, because of that base current is increasing. Okay, so it is not affect the lifetime of the carrier and diffusion capacitance, dynamic resistance of the junction. It does not depend. So this is also not related this. Next, early voltage. First you should know what is early voltage. Early voltage is nothing but it is a voltage between collector to base. It is a voltage applied between collector to base region, collector to base junction, to make the effective base width become 0. Now I am going to writing that value, writing that equation. First, what is early voltage? You should know that. So early voltage is the voltage at collector junction at which the effective base width became 0. Voltage, it is the reverse voltage. Reverse voltage. That means that collector base junction should be reverse bias. It is the reverse voltage at which it is the reverse voltage at which the effective base width it is the reverse voltage at which the effective base width equals to 0. Equals to 0 means the total base region should be filled by the total base region should be filled by total base region should filled by depletion region. See, now once this junction between collector to base, this is collector and base, initially only this is the base width. To make this base width completely depletion region, we need some early voltage. Here once width of the base is increasing, you need to spend additional voltage, you need to add to make this additional base region what is increased also into depletion region. To convert that one also into depletion region, you need a additional reverse voltage you need to apply it between collector to base. Okay, so early voltage, whatever the early voltage initially we have, now it is going to be increased. So this is the correct option for this. That is the correct option for that. Next one. See here they given a problem on device circuit. In the circuit in the figure, the BJT has a current gain beta of 50. Okay, they given beta value 50. For an emitter base voltage VEB 600 millivolts. This is the emitter, arrow mark is there, it is emitter. Emitter to base voltage plus minus 600 millivolts means 0.6 volts. The emitter collector voltage in volts. What is this voltage between these two? Emitter and collector. VC is how much? As usual, first I am going to applying KVL to input loop. Applying KVL to input loop. And this is the base terminal. This is base current. So applying KVL to input loop. KVL to input loop. 3 equals to 0.6 plus IB times 60K. 60 kilo ohms. Therefore IB is 3 minus 0.6 by 60K. That is a 2.4 by 60K. So this 3.4, 2.4 by 60 is 3.4 milli. sorry, 2.4 divided by 60, it is 0.04 milliamps. So we can write it as 40 microamps. That is the IB value. So this is IE. This is the direction of currents here. IE, IB, IC. Next I am going to calculating IC value. Now IC is simple beta times IB. So beta 50 into IB value 40 micro. It is 2 milliamps. Now this is the voltage at a collector. Voltage at collector VC is 500 into IC. 500 ohms into IC. That is 500 into 2 milliamps. It is 1 volt. Now voltage at emitter already they given, it is 3 volts. Now VCE is voltage at collector minus voltage at emitter. Voltage at collector is given 3 voltage at, sorry, they want VEC. So they want VEC. VEC is voltage at emitter minus voltage at collector. That is voltage at emitter is 3 volts minus voltage at collector is 1 volt. That is 2 volts. So VEC value is 2 volts. So this is the procedure to analyze a circuit. From this we calculate all terminal currents and voltages. See this. If you want emitter current IE, we know that IB plus IC. IB plus IC. Or simply 1 plus beta times IB. Okay. So just before we know IB we calculated and IC also we know. And beta they given. So from this you get the IE value. So to calculate anything in the transistor, the first step is calculation of input current. Because our current transistor is a current controlled current device, input control current is going to control the output things. That's why first you need to calculate that controlling parameter at input side, input current. Okay, so please take a note of this one. This is very important. Next. So a BJT is biased in small forward active mode. So BJT is in forward active region. Assume VBE 0.7 volts. Sorry, it is volts here. VBE base to emitter voltage is 0.7 volts. And KT by Q VT 25 millivolts. KT by Q is VT 25 millivolts. And reverse saturation current IS 10 power minus 13 amps. The transconductance of BJT in milliamps per volt is, see, transconductance of BJT is GM, which is mod IC by VT. That is the transconductance of GM. Transconductance GM of BJT. Mod IC by VT. So just calculate the IC value from given data. So from this I am writing IC is reverse saturation current into e power VBE by VT. So e power IS is 10 power minus 13 into e power 700 by 25 milli. 700 milli it is 25 milli. Milli gets cancelled. Okay, now it is a 10 power minus 13 into e power 28. So get the value of e power 28. E power 28. It is 1.4 into 10 power 12. 10 power minus 3 into 1.4 into 10 power 12. So it is a 1.4 into 10 power minus 1. That is 140 milliamps. That is IC. Just substitute that IC here. 140 milliamps by VT. VT value they given KT by Q 25 millivolts. So VT is 25 millivolts. But they want in terms of volts, milliamps per volts. This is milliamps per volts. In volts it is 0.025 volts. So 0.025 volts. Now 140 by 0.05, that is the transconductance. That is 5600 milliamps per volts. These are the units, milliamps per volts. That is the transconductance of the transistor. Okay. So like that you have to solve the problems. So next problem, we move to next one. Now in a certain transistor, the collector current they given collector current 0.98 milliamps and base current 20 microamps. The values of emitter current in milliamps and current amplification factor respectively are. First they want emitter current, sir. We know that emitter current is base current plus collector current, IB plus IC. Okay, they given IB value 20 micro, that means 0.02 milli amperes plus IC value 0.98 milliamperes, that is 1 milliamp. IE is 1 milliamp. So option is either A, either C or either D, because in option B it is 0.02. So now emitter current is over. Next they want current amplification factor. If you observe one thing, current amplification factor means transistor is operating in three different regions. Common base current amplification factor alpha, common base current amplification factor alpha, common emitter amplification factor beta, and common collector amplification factor gamma. Now which one here they want? Now if you observe the approximate values, alpha is approximately 1, beta is much value, it is greater than or equal to 50, and gamma is greater than beta. Okay, these are the values. Now these two are very much greater compared to 1. Now here you observed option First case they given 1.02, 0.98, 0.02. Now the option is required one is alpha itself. Now the second options, current amplification factors which are given is close to 1. That means they want alpha. Therefore alpha is common base configuration, common base current amplification factor. Output current IC by input current IE. IC they given 1.98 milliamps, 0.98 milliamps by IE 1 milliamp. So that is 0.98. That is the alpha value. So alpha is 0.98. So IE is 1 milliamp and alpha is 0.98. So this is the correct option. C is the correct option. So like this, based on the options also you need to choose which one we need to calculate. Okay. Now I am moving to next problem. See, the collector and base currents of NPN transistors are measured as IC they given, base current they given, IC B0 they given. Determine the new level of base current in microamperes required to produce 10 milliamps of collector current. They want 10 milliamps of collector current. To produce that, what is the base current required? So first they given this data, IC they given, IB they given, IC B0 they given. We know one thing, IC B0 is nothing but a IC naught. So now the relation between, to cover all these parameters is, we have a relation that is IC equals to beta times IB plus 1 plus beta times IC naught. Okay, now IC they given as, substitute just values, 5 milliamps. Beta they did not given, we need to find the beta from this. IB is beta times IB is 50 micro. 50 micro. 50 micro. Micro is 10 power minus 6 plus 1 plus beta into IC naught. IC naught. IC naught value is 1 micro. So here I am taking this one also in micro. మా పక్కన అడుగమ్మా. It is micro. Open. Beta times 50 into, so it is micro. Just a minute. Beta into 50, sorry, IB 50 micro. 50 micro plus plus 1 plus beta. 1 plus beta times 1 plus beta times IC naught value is 1 micro. 1 micro. Now this is total 50 beta and it is 151 beta. Sorry, it is 1 micro. Now I am writing it is 500 micro equals to 1 micro plus 50 beta and this is 1 beta. 51 micro into beta. So now it is Now it is 4,999, 4,999 4,099 mu micro is equals to 51 micro beta. Beta gets cancelled. Now beta value is mu gets cancelled. It is a 4,999 mu is equals to 51 mu into beta. Mu gets cancelled. Now beta value is 4,999 by 51. So just get the value of that. 4,999 by 51. It is 98. Approximate value of this one is 98. The exact value 98.0196. So approximate is sufficient. 98 beta value. So that is the beta value. Now I am going to claiming new things. Here I want to get IC value 10 milliamps with the transistor beta value of 98 and IC naught value I have 1 microamp. With these values I want to get the beta value. What is the IB? Now I am doing this. It is 10 milli is equals to 98 times of IB beta IB plus 1 plus 98 into IC naught 1 micro. So the same equation I am using here. IC is beta times IB plus 1 plus beta times IC naught. I am using the same thing. 99 into 1, 99 micro. Now it is 10 milli. So it is 10 milliamps minus 99 micro. It is 0.099 milli is equals to 98 into IB. So 10 minus of that 0.099 divided by 98. That is 0.1. IB is 0.101 milliamps. Okay. In terms of microamps, 101 microamps. That is the base current value. Now this is the option. That is the right option. 101. Okay. See, they split this problem into two parts. We split it. First, they given some set of data. They did not given the beta value of the transistor. By using the given set of data, first we calculated the beta value, and after that we calculated this. By using that beta and given data, we calculated the base current. So you can see this problem in two different ways, like this. Now the next problem is the reverse saturation current of an NPN transistor is in common base circuit. Reverse saturation current in common base circuit is ICB0. They given as ICB0. It is 12.5 microamps. We know that this is, you can claim this is nothing but a IC0. Already we analyzed this part and we defined this equation first first slide itself. For a emitter current of 2 milliamps, so for a emitter current of 2 milliamps, the collector current is 1.97 milliamps. Collector current is 1.97 milliamps. The current gain and base current respectively. Current gain means alpha because it is in C common base, and base current is how much? Simple thing, sir. We know emitter current equals to base current plus collector current. Equals to base current plus collector current. First we need base current. Therefore base current is IE minus IC. Simple. IE minus IC. Just substitute the values. IE value is 2 milli minus it is 1.97 milli. That is 0.03 milliamps. That is the IB value. Next, current gain alpha. For in CB configuration, current gain is IC by IE. IC is 1.97 milli by IE is 2 milliamps. Milli gets cancelled. It is 1.97 by 2. 0.985. So approximately you can take it 0.99. Okay, so 0.03 milliamps of base current and 0.99 or 0.985 approximate. So this is the right option. This is the option. Now, which of the following statement is true with regards to the BJT? Now the first one is the base width must be designed to be larger than the minority carrier diffusion length. The base width must be designed to be much smaller than the minority carrier diffusion length. See this? Here this is the constraint on complete the width of the base region. What you are taking is the point here. So this is emitter, let us assume, and this is the base. Okay. Emitter, base, and collector. Now emitter is, let us take PNP transistor, P plus N minus. Emitter is heavily doped, base is lightly doped. Now base width, if you observe the physical widths of each and every region, the width of this emitter is moderate in size and the width of collector is large in size, but the width of base is very small in size. Now our intention in transistor is to transfer the majority of the charge carriers which are emitted by the emitter has to be forwarded to collector through base with less recombination in it. To support less recombination, the base with the base is lightly doped. Base is lightly doped because of this, to support less recombination. Now even though it is doped lightly, if carriers which are emitted by the emitter and once entered into base, if they have a low value of lifetime, then that most of the carriers are going to be recombining base itself. But these charge carriers, most of these charge carriers has to reach the collector. For that lifetime of the carrier should be much greater than the width of the base. lifetime of the charge carrier. Emitters are from emitter holes are entering. Now lifetime, sorry, diffusion length. Okay, diffusion length should be much greater than phase width. Then only the transistor action what you say is going to satisfy here. Okay, so this is the option. The base width must be designed to be much smaller than the carrier diffusion length. This is this smaller than the carrier diffusion length, this one. Okay, so this is the, it is a good question. Now base width modulation in a BJT results in, see, it results an increase in the output conductance. Due to base width modulation, collector current is increasing. Once collector current is increasing, output conductance is output current by voltage. So output conductance of the device increases. Now see this problem. Just take this circuit diagram. Now see this, for the circuit shown in the figure, assume that the BJT has a large beta value. See, clearly they mentioned it is BJT is large. BJT has a large beta. Suppose RC is selected. So RC value is selected to ensure BJT operation in active region. Okay, BJT is in active region. BJT is in active region. What is the collector current IC? What is IC? See, the general way we to calculate this parameter IC is first step we calculate IB. Second step, IC is beta times IB. IC is beta times IB. This is the procedure we are following to calculate the IC value. Okay, so we need for that beta, but the given beta is a large value. So large value means which one you take? You can't take specific value. Okay, given just by a word large. They did not define it by a specific value, 100, 150, 98, okay, 50, like that. They did not give a value. What is the meaning of beta is large? Just we analyze. This. See, our equation is IE equals to IB plus IC. So IC plus, okay, IB I am taking opposite. Now IC plus, we know already IB is IC by beta. IC by beta. Now just take IC common. 1 plus 1 by beta. If beta is large, then we can write beta is large, then we can write 1 by beta is very much less than compared to 1. If beta is large, 1 by beta is much less than 1. Now it is much less than 1 compared to, it is much less. At that time you can write IE is approximately IC into 1. Therefore IE is approximately IC. So whatever the emitter current you have, that is equals to collector current under beta is large condition. So that means you can treat IB approximately 0. It means IB approximately 0. Okay. Now I'm going to this problem. Okay, default you can take base to emitter voltage 0.7. So this is 0.7. Current through this one is, it is emitter terminal, it is IE. Just apply KVL to this loop, and this is base current IB, it is approximately 0. Now, so apply KVL to this loop. Now I am applying KVL to this loop. By applying KVL to this loop, 0 equals to 0.7 plus IE times RE, it is 2K minus 5. So now it is 5 minus 0.7, it is 4.3. Therefore IE equals to 4.3 by 2K. Just to get the value, 4.3 divided by 2K is 2.15 milliamps. 2.15 milliamps. See, just before you defined previously, just before you defined IE is nothing but IC if beta is large. The same thing I am applying here. This is nothing but your collector current. IE is equals to IC, 2.15 milli. So this is the option. Two 2.15 milliamps. Okay, that is the value. So next problem. For the circuit of question 16, that means previous question, what is the condition on RC which ensures that the BJT operates in active region? Which ensures that the BJT operates in active region. See this. First I am going to drawing the circuit diagram. This is the circuit diagram what they given in previous case. This is the circuit they given. Now it is 5 volts minus 5 volts. 5 volts, it is minus 5 volts. It is 2 kilo ohms they given. Now it is RC. Okay. So to operate this transistor in active region, I want to operate this transistor in active region. For operating this in active region, what is the condition on RC? That means what is the value of RC? Just before we calculated from previous question, from question number 16. See, in 16 question also, your transistor is operating in active region itself. We calculated already collector current from this, it is 2.15 milliamps. From question number 16, IC value is 2.15 milliamps. Okay. So to ensure this transistor is in active region, whatever the collector current you calculated, it should be greater than IC maximum. So whatever the collector current you calculated, that collector current should be maximum collector current possible in this circuit. Then only you can say your transistor is operating under active region. So what is IC maximum? IC maximum is nothing but a saturation current. IC saturation. Saturation collector current is the IC maximum. Now the IC maximum from this circuit is, you can take it is VCE saturation here. VCE saturation. Okay. Now it is, just apply KVL with a collector current of IC maximum. This is IC maximum, this is IC maximum. In this problem they did not give any value related to EC saturation, so you can assume approximately 0 it is. Now apply KVL to this. Okay, therefore by applying KVL to that, you get 5 equals to IC maximum into RC plus 0 VCE saturation plus IC maximum into 2K minus 5. Take this one this side, it is a 10. Therefore IC maximum is 10 by RC plus 2K. RC plus 2K. This is the value of IC maximum. Now just substitute this one here. Already we know IC, it is 2.15. Therefore 2.15 milli greater than 10 by RC plus 2K. Now it is 2.15 milli into RC plus 2.15 into 2K. 0.15 into 2K, that is 4.3 greater than 10. K and milli gets cancelled. Therefore RC value is greater than, RC is greater than sorry sir, just a minute. Sorry, it is this should be less than maximum collector current. I am very sorry, small confusion. It is active region. Generally they ask the questions like this on saturation. Now IC should be less than maximum collector current. RC is less than, take this one this side, 5.7 by 2.15 milli. 5.7 by 2.15 milli. It is 5.7 divided by 2.15, that is 2.65 kilo ohms. Therefore the RC value should be less than 2.65 kilo ohms. To keep your transistor in active region, RC value should be less than 2.65 kilo ohms. If it is greater than, it will enter into saturation. That's it. Simple thing. If it is greater than, transistor entered into saturation region. Is it okay, sir? So like this you can solve your problems. So we have a few more problems left. So next session we go on solve these problems. So we have few more problems. Next session we go on solve these problems. Once again, I am requesting all the students, please take a note of these formulas. What we mentioned in first slide, please use these formulas. This complete problem session depends on these formulas only. Okay, these formulas, and one more you can write. Let us take a transistor. So transistor, this is the procedure to calculate IC. First calculating IB. So next calculating IC is beta times IB. From circuit we calculate IC maximum possible collector current. So the maximum possible collector current in a circuit is VCC by RC plus RE minus VCE saturation here. This is the maximum possible collector current, or IC saturation you can also call it. For saturation region, to operate your transistor in saturation region, whatever the IC you calculated here should be greater than or equal to IC maximum. Then your transistor is in saturation region. Okay. Or you can calculate IB from this. IB minimum you get. IB minimum is written as IC maximum by beta. That is the minimum base current required to enter your transistor into saturation. And IB is greater than or equals to IC or IB minimum. So if base current is greater than or equals to this minimum base current, then your transistor is entered into saturation region. So you can expect this type of questions also. They will give something to you, some circuit to you, and some data related to that they will provide. You need to identify the conditions on different elements, either base, emitter or collector, maybe current or resistance values. Okay, you need to calculate that based on the question they given. Already we solved 2 or 3 problems on this. So next class we solve the remaining part. I'm thanking to one and all for spending your valuable time with us. Don't forget to use my code during subscription VROUT10. Don't forget to use, and please hit the bell icon for getting notifications, and don't forget to subscribe us. Please give your valuable comments on this to strengthen ourselves and to provide a better and quality information to the upcoming students. Please join our Telegram group for latest updates on our upcoming videos. So once again, I am welcoming you all to this beautiful online learning platform. Thank you. Thank you very much. Thanks for spending your valuable time with us. Thank you. Thank you very much.